We've got our baseball data imported here. We've got the names of the players, position they played, these position dummies, our 3-year OPS, so this is a measure of their hitting ability, their salary, annual salary in the first year of their contract, and natural log of their salary. Okay, let's analyze this in regression. Analyze regression, linear regression. We're going to pick at first salary as our dependent variable, and then the 5 position dummies and 3-year OPS as our explanatory variables. Would like to see the weight test, so let's go there and click weight test for heteroskedasticity, and we'll hit run. We're going to see a lower r squared here than we are possibly used to. Relatively large data set, so it's going to complain at us a little bit, but not too bad unless your computer's really weak. We've got an r squared of only around 40%, but this is entirely natural with this type of data, so we're not going to be too concerned about that. We have most of our variables are significant. The only one that's not is our outfield variable. Our omitted category here is first base. So that's telling us that our outfielders and first basemen earn about the same salary. Scrolling down, we're going to see our residual by predicted plot. And here we've got that classic fan shape to our residuals. So for low values of the predicted y variable, we've got small residuals. As we get to larger predicted values, we've got larger and larger residuals. Okay, so we need to do something about that. Our weight test confirms that we've got heteroskedasticity, but, well, we could definitely see that with our eyes anyway. Okay, one way that we can fix this is by switching out our dependent variable for the natural log of the dependent variable. So log salary is now going to be our dependent variable. Let's hit run. We're going to see another significant regression, but one that's got a lower r squared this time. That, for a lot of people, is concerning at first. It might suggest to them that we've done something bad. But we actually can't compare r squareds across regressions when we have changed our y variable. So you should not be concerned about this. You should rely more on our other fit statistics other than r squared and adjusted r squared here. And again, we've got all of our variables are significant again. We've got a much better looking residual by predicted plot. So we've got a plot that looks a lot more like a blob than the fan shape. There's still maybe a little bit of fanning to it, but while the residuals seem to be getting bigger around here, they're getting smaller around here, so we're not going to be too concerned about that. The weight test, on the other hand, is convinced that we've got heteroskedasticity. So it's for this sort of reason that I tend not to trust that weight test and try to use the eyeball test and these residual by predicted plots or residual by x variable plots in order to detect heteroskedasticity.